Next application is so-called Newton's law of cooling. And here what we want to do is to solve the following problem. Suppose that you have an object that I sketched in here that has initial temperature T0. So let's say T initial temperature. T of 0 is equal to some known temperature T0. And you take its object and you bring it into an environment with a temperature TE. And you want to see how the temperature of the object will evolve in time. So in order to figure out how this evolution happens, what we need to do again is to design an ODE which will govern the evolution of a temperature. And to construct this ODE, we have to understand what's going on with the rate of change of a temperature. All right, so the rate of change of temperature, of course, is given by its derivative with respect to time. So it's T prime of T, and we have the following facts about that. So facts, number one, if T of T is less than the temperature of the environment, then what do we expect to happen with the temperature of the object? If temperature is less than the temperature of the environment, heat is going to be passed from the environment to the body, and so that means that its temperature is going to grow. So if the temperature is going to grow, and then that means that T prime is going to be greater than 0, right? Because the temperature is increasing. Number two, if temperature of a body is greater than the temperature of the environment, then the body is going to lose heat and its temperature is going to go down, so T prime of T will be less than 0. And finally, if T of T is equal to T, if there is a temperature equilibrium between the body and the environment and there is no heat exchange, so then T prime of T is equal to 0. So notice that we are making one assumption here. That make an assumption that the temperature is going to stay constant within the body. So if a heat rises on a boundary, it immediately gets dissipated throughout the entire body. Because if that was not true, then the temperature will depend not only on time, but also on the position inside the body. So temperature will be a function of two variables, and then the equation that we'll have to produce would be not an ODE, but PD, because it will have partial differential equation, because it will have it will be described, the temperature distribution will be described by a function of two variables, time and space. So that the temperature is the same throughout the body. Okay, so knowing this, we need to come up with some sort of expression for t prime of t, which will satisfy the conditions from 1 to 3. All right, so